In this video, we're going to solve equations using the zero product property. We will do a lot of factoring in this video, and for this video, I'm going to assume that you have a basic understanding of factoring. If you'd like an introduction and review of factoring, please watch my Chapter 4.4, Chapter 4.5, Chapter 4.6, and Chapter 4.7 videos. Let's start with the zero product property. The zero product property says if the product of two factors is zero, then at least one of the factors is zero. In other words, if A times B equals zero, then A must equal zero, because then you would have 0 times B, which equals 0. Or instead, B could equal 0, because then you would have A times 0, which equals 0. Or both A and B could equal 0, because then you would have 0 times 0, which equals 0. And the zero product property does not only apply if you're multiplying two quantities together. This property applies if you're multiplying any number of quantities together and the product is equal to 0. Let's take a look at how we can apply the zero product property. We're asked to solve this equation here. Now this equation is already in factored form. We can view this as if we're multiplying three quantities together. We're multiplying 4p times p plus 2 times 3p minus 4. The zero product property says in order for this product to equal 0, at least one of these quantities has to be 0. So one possibility is that 4p equals 0, because then this quantity would equal 0, and we would have 0 times this quantity, which would in fact equal 0. The other possibility is that this factor is equal to 0, because then we would have 4p times 0 times 3p minus 4, which would in fact give us 0. And the last possibility is that this factor here could equal 0, because then we would have this factor times 0, which would equal 0. Then we want to solve each equation. To solve this equation here, we want to isolate p, and to do that, we need to divide by 4. These 4's will cancel, and we'll be left with p is equal to, and 0 divided by 4 is 0. Next, let's solve this equation here by subtracting 2 from both sides, and that leaves us with p is equal to negative 2. And to solve this third equation here, we want to isolate p. To do that, let's start by adding 4 to both sides. That will leave us with 3p is equal to 4, and then we'll divide both sides by 3. That will leave us with p is equal to 4/3. So we have three solutions here. P equals 0, P equals negative 2, and P equals 4/3. If you'd like to check your work, you'll have to check each answer separately. Start by plugging in 0 for each of these P's, and when you compute this, you will get 0. Then plug negative 2 in for each of these P's, and when you compute this, you'll get 0. Lastly, you'll want to plug in 4/3 for each of these P's, and when you compute this, it will equal 0. You can write your final answer like this, or if you're asked to write your final answer in solution set notation, we'll draw these curly brackets, and then we'll just list each answer and separate it with a comma. With solution set notation, you don't have to list your answers in any particular order, but most textbooks list the answers from least to greatest. So I'm going to start with negative 2, then we'll list 0, and then we'll list 4/3. Now notice this first example was already written in factored form. For all of the future examples, our problems will not be factored for us. We're going to have to first write our problem in factored form and then use the zero product property to solve. We're going to first use the zero product property to solve quadratic equations. A quadratic equation is a polynomial equation that can be written in the form ax squared plus bx plus c equals 0. A quadratic equation means that you have an x squared. And quadratic equations don't have exponents higher than squared. So quadratic equations cannot have x cubed, x to the 4th, x to the 5th, and so on. Let's look at some examples of quadratic equations. Here's an example of a quadratic equation. Notice we have an x squared term. Here's another example of a quadratic equation. Notice quadratic equations are required to have a squared term, but they are not required to have an x term or a constant. As long as you have a squared term, you can call it a quadratic equation. Here's another example of a quadratic equation. Here are two more examples of quadratic equations. Notice these quadratic equations aren't equal to 0, like we showed here, but as long as it can be written in this form, you can call it a quadratic equation. So we could rewrite these two equations to have them equal 0. Here's another example of a quadratic equation. While you can't immediately see the x squared term here, if you were to FOIL this out, the x times the x would give you x squared. Next, we're going to discuss the standard form of a quadratic equation. The standard form of a quadratic equation will look like this. If we look over here, which of these equations are written in standard form? These top three equations are all written in standard form. How do we know that? Well, let's go over the requirements of standard form. For a quadratic equation to be written in standard form, the equation must be equal to 0. All three of these equations meet that requirement. They're all equal to 0. In addition, in order for a quadratic equation to be written in standard form, the variables must be listed so that their exponents are in descending order. So your x squared term should be written first, your x term should be in the middle, and your constant should be last. And again, for quadratic equations in standard form, you are required to have an x squared term, but you are not required to have an x term or a constant. For these top three equations, all of their variables are listed so that their exponents are in descending order. The last requirement for standard form is that there are no parentheses. None of these equations here have any parentheses. Notice these bottom three equations are not written in standard form. These two are not in standard form since they are not equal to 0. This bottom equation is not in standard form for two reasons. One, it is not written so that it's equal to 0, and two, there are parentheses. Now that we've discussed the standard form of quadratic equations, let's take a look at some more examples. So next we're going to learn how to solve quadratic equations by factoring. Here are the steps that we're going to follow for each problem. Let's look at this example here. If you see a quadratic equation, you'll know it's quadratic because you see an x squared term, and you'll know it's an equation because you'll see an equal sign. If you see a quadratic equation, and if you're asked to solve, step 1, we need to write our equation in standard form. If we look back at the previous page, these are all of the requirements for standard form. Your equation must be equal to 0, the exponents must be written in descending order, and there should be no parentheses. So to write this in standard form, we need to get it equal to 0. To do that, I'm going to add 6 to both sides. Then we'll make sure to write our x squared term first, our x term in the middle, and our constant last. And negative 6 plus 6 gives us 0, so we have our equation equal to 0. Now our equation is written in standard form. Let's move on to step 2. For step 2, we're going to factor completely. Notice here that this is a trinomial. We call it a trinomial because it has 3 terms. In my chapter 4.5 video, we learned how to factor trinomials. The first step in any factoring problem is always to check for a greatest common factor. This particular equation has no greatest common factor. The next step of factoring a trinomial is we need to find two numbers that multiply to give us the product of a times c, where a is the coefficient of the x squared term and c is the constant. That would give us 1 times 6, which gives us 6. We need those same two numbers to add to give us b, where b is the coefficient of the x term, so that would be negative 5. The two numbers that work are negative 3 and negative 2. Because negative 3 times negative 2 gives us 6, and negative 3 plus negative 2 gives us negative 5. Now, when you're factoring trinomials, if the coefficient of the x squared term is a 1, once you have these two numbers here, you can go ahead and write your problem in factored form. We'll start with our parentheses, and since this is a 1x squared, we'll put a 1x and a 1x in the first position in each parenthesis. And then we'll insert these green numbers in the blanks. So we'll put a negative 3 in one parenthesis and a negative 2 in the other. Now, a common mistake is to stop here. We're so used to factoring that it's tempting to stop once you've factored. But this problem doesn't ask us to factor. The problem asks us to solve. And keep in mind, the problem that we were factoring right here is equal to 0. We need to copy that equals 0 down. Now that we've factored, in order to actually solve this, we need to move on to step 3. For step 3, we need to set each factor that contains a variable equal to 0 and solve. I'm going to copy this down right here. So factors are quantities being multiplied. We have two factors here since we have two quantities being multiplied. X minus 3 is a factor and x minus 2 is a factor. So let's set both of those factors equal to 0. We'll start by setting x minus 3 equal to 0, and then we'll set x minus 2 equal to 0. Now we just need to solve each of these equations. To solve this equation, for x, we'll add 3 to both sides, and that will leave us with x is equal to 3. To solve this equation, we'll add 2 to both sides, and that will leave us with x equals 2. And our final answer can be written like this, or if you're asked to write your final answer using a solution set, you would just insert your two answers inside curly brackets and separate them with a comma. Keep in mind that you can check your work for these types of problems. You just want to plug each of your answers into the original problem. First, let's check the answer x equals 2. Plug in 2 for each of these x's, and when you compute this, you should get negative 6. Then let's check x equals 3. To check that, you plug 3 in for each of these x's, and when you compute this, you should get negative 6. Let's take a look at the next example. Again, we're asked to solve this equation, and notice that this is a quadratic equation since we see an x squared term. So when you're solving a quadratic equation, we follow these steps in this box here. Step 1, we need to write our equation in standard form. To get this in standard form, let's start by getting it equal to 0. So we need to subtract 147 from both sides. Now when we write this expression in standard form, we make sure to put the x squared term first, so we'll write 3x squared, and then we'll write the constant last, so we'll write minus 147. On the right side of the equation, 147 minus 147 gives us 0. So we've now written this in standard form. It meets the three requirements that we wrote on the first page. This equation is equal to 0, the exponents on the variables are written in descending order, and there are no parentheses. Now that we've written our equation in standard form, we can move on to step 2. For step 2, we factor completely. Whenever you're factoring, the first step is to check for a greatest common factor. The greatest common factor here is 3. So since there is a greatest common factor, we need to factor out the GCF. We'll put the greatest common factor outside of parentheses. Then 3 times x squared will give us our 3x squared. And if we take negative 147 divided by 3, you get negative 49. So 3 times negative 49 will give us negative 147. So we've factored out the greatest common factor. Now don't forget that this is equal to 0, so our factored form also has to be equal to 0. Now that we've factored out the GCF, we're going to just ignore it for a moment as we focus on factoring this expression here. Notice this is a binomial. We call it a binomial since it has two terms. In my chapter 4.6 video, we learned how to factor binomials. When you factor binomials, you have to decide if you're dealing with perfect squares or perfect cubes, because that will tell you which formula to use. This x squared is a big hint that we're probably dealing with perfect squares. 49 is also a perfect square. So we're dealing with two perfect squares here with a minus sign in the middle. When that's the case, we call this the difference of two squares, and we factor it using the difference of two squares formula, which is a minus b times a plus b. To use this formula, we just have to find our a and our b and plug that into the formula. You might be able to do this mentally at this point, but if you're not sure how to do this mentally, to find a, I recommend that you write this first quantity as some quantity squared. X squared can be rewritten as the quantity x squared. To find b, I recommend that you rewrite 49 as some quantity squared. 49 can be rewritten as 7 squared. The quantity inside these first parentheses in light purple here is our a, so a is equal to x. And the quantity inside these second parentheses here in light purple is b, so b is equal to 7. Now we just need to plug these values into this formula here. So we'll plug in x for a and 7 for b. That gives us the factored form x minus 7 times x plus 7. And again, don't forget that this is supposed to be equal to 0. And then don't forget that we need to include our GCF in our factored form, so we'll write the GCF out front. Now, since we've had so much practice factoring, a lot of people are tempted to stop here once they've factored. But be careful, the instructions for this problem do not say to factor. The instructions say to solve the equation. So when you're asked to solve a quadratic equation, after you've factored, you need to move on to step 3. For step 3, we set each factor that contains a variable equal to 0. To start, I'm going to copy this equation down here. Remember that factors are quantities being multiplied. So this is 3 times this quantity times this quantity. So we have 3 quantities being multiplied here, which means that we have 3 factors. 3 is a factor, x minus 7 is a factor, and x plus 7 is a factor. Now notice the instructions say set each factor that contains a variable equal to 0. This factor here, 3, does not contain a variable, so we're not going to set it equal to 0. If we did, we would write the statement 3 equals 0, which is a false statement, meaning there is no solution here. So if one of your factors does not contain a variable, you do not have to set it equal to 0. So we'll write x minus 7 equal to 0, and we'll write x plus 7 equals 0. And now I'm going to proceed to solve these two equations. And we end up with two answers, x equals 7 and x equals negative 7. Let's take a look at the next example. A very common and tempting mistake is that someone might notice that this left side is factored. And a common mistake is to now either go ahead and set each factor equal to 0, or some students will try to set each factor equal to 9 since they see a 9 here. This will not give you the correct answer. That's because you can only use that zero product property when your factored form is equal to 0. Here, our factored form is equal to 9, so we cannot use the zero product property where we set each factor equal to 0. Since our factored form is not equal to 0, we have to proceed through those steps that we saw on the previous page. First, we need to write our equation in standard form. Remember, in standard form, those 3 requirements that must be met. Our equation must be equal to 0, the variables must be written so that their exponents are in descending order, and there must be no parentheses. I'm going to start by copying this given equation down here. To start, for standard form, we should have no parentheses. So I'm going to FOIL this out in order to get rid of the parentheses. We'll multiply x times x to get x squared, then we'll multiply x times 5 to get a positive 5x. We'll take negative 3 times x to get a negative 3x, and we'll take negative 3 times 5 to get negative 15. Then don't forget the equal 9. And now we'll just combine some like terms. If we take 5x minus 3x, that will give us a positive 2x, and we'll bring down the minus 15 and the x squared. And we'll make sure to keep this equal to 9. Now we're getting closer to standard form. Our equation is written with no parentheses. Our variables have the exponents written in descending order. The only thing we still have to fix is that our equation is not equal to 0. So let's subtract 9 from both sides to get our equation equal to 0. That will leave us with x squared plus 2x minus 24 is equal to 0. Now our equation is written in standard form. Only after your equation is written in standard form can you proceed to step 2. For step 2, we want to factor. The first step whenever you're factoring is to check for a greatest common factor, but this trinomial has no greatest common factor. Now, to factor this trinomial, we need to find two numbers that multiply to give us negative 24. Negative 24 is the product of a times c, which is 1 times negative 24. We need those same two numbers to add to give us the coefficient of the x term, which is 2. The two numbers that work are negative 4 and 6, because negative 4 times 6 gives us negative 24, and negative 4 plus 6 gives us 2. Since the coefficient of the squared term in this trinomial is a 1, once we find these two green numbers, we can go ahead and write our factored form. We'll start with our two sets of parentheses, and since this is a 1x squared, we'll put a 1x and a 1x in the first position in each parenthesis, and then we'll insert these green numbers in the blank. We'll put a negative 4 here and a positive 6 here. Now there's no GCF that we need to put out front, but we do need to remember that we are factoring this equation, and this equation is equal to 0. So we need to make sure to set this factored form equal to 0. Now that we've factored, we'll move on to step 3. Step 3, we set each factor that contains a variable equal to 0. I'll start by copying down this factored equation. We have two factors here, so let's go ahead and set each factor equal to 0. We'll set the factor x minus 4 equal to 0, and we'll set the factor x plus 6 equal to 0. Now we want to solve both equations. If we solve this equation here by adding 4 to both sides, that will leave us with x equals 4. And if we solve this equation here by subtracting 6 from both sides, that will leave us with x is equal to negative 6. So these are our two answers, and if we're asked to write our answer using a solution set, our answer would look like this. Let's take a look at two last examples. Now, we've been factoring quadratics. A quadratic always has an x squared term, and it never has anything higher than an x squared. So a quadratic won't have an x cubed, an x to the fourth, an x to the fifth, or anything higher. These two equations here are not quadratics. This has an x cubed and an x to the fourth, so it's not a quadratic. Same here, this equation has an x cubed, so it's not a quadratic. But we're going to see here that we can actually use those same steps that we learned on page 2 for factoring equations even if they aren't quadratic equations. Step 1, we want to write our equation in standard form. To do that, we want to get the equation equal to 0. So let's subtract 36x from both sides. Now, remember that standard form means that your variables are listed with the exponents in descending order. So from left to right, you'll go from highest to lowest. So we'll start with the highest exponent, x to the fourth, then we'll write plus 4x cubed, then negative 9x squared, then negative 36x. And then we'll write equal, and 36x minus 36x gives us 0. Now our equation is written in standard form. It meets those 3 requirements that we learned on the first page. Our equation is equal to 0. The variables are written with their exponents in descending order, going from highest to lowest, and there are no parentheses. So now we can move on to step 2. For step 2, we're going to factor completely. The first step in any factoring problem is to check for a greatest common factor. The greatest common factor here would be x. So since there is a greatest common factor, we need to factor out that greatest common factor. To do that, we write the greatest common factor outside of parentheses, and then we think through, what do we have to put inside these parentheses so that when we distribute the x, we get this expression here? Well, x times x cubed will give us x to the fourth. Remember, when you multiply variables, you add their exponents. So the exponent 1 plus 3 gives us 4. Then x times 4x squared will give us 4x cubed. X times negative 9x will give us negative 9x squared. And x times negative 36 will give us negative 36x. And then we'll make sure to bring down our equals 0. Now that we've factored out the GCF, we want to make sure to include the GCF in our final factored form, but we can ignore the GCF just for the time being as we focus on factoring this expression here. Notice this expression here has 1, 2, 3, 4 terms. We learned that in order to factor expressions involving 4 terms, we must factor by grouping. So we'll group these first 2 terms together, and we need to factor the GCF out of these 2 terms. The GCF between x cubed and 4x squared would be x squared. X squared times x will give us x cubed, and x squared times a positive 4 will give us 4x squared. So we factored the GCF out of these first 2 terms. Now let's focus on these last 2 terms. We need to factor the GCF out of these 2 terms. When we're focusing on these last 2 terms, let's first notice that the first term is negative. So that means that our GCF must be negative. So I'm going to start by writing a negative here. Then the largest number that multiplies into 9 and 36 is 9. So our GCF is negative 9. Now let's factor negative 9 out of this expression. Negative 9 times x will give us negative 9x, and negative 9 times a positive 4 will give us negative 36. So now we factor the GCF out of these last 2 terms. Now I like factoring by grouping because you can always check your answer at this point. You should have 2 matching factors, and we do, so it looks like we're on the right track. Now, to write this in factored form, let's start by writing this matching factor once here, and then in the next factor, we'll insert these outliers. So we'll write x squared and minus 9. Now we're forgetting 2 things. 1, we need to make sure to bring down the greatest common factor, and then we need to make sure to include the equals 0. Now in step 2, we want to factor completely. Have we factored this as much as we possibly can? Remember, there's one thing that often sneaks up in your answers when you're factoring. That is the difference of 2 squares. Whenever you're factoring, you want to double check all of your answers to see if you see the difference of two squares anywhere. This right here is the difference of two squares. And we factor the difference of two squares using the formula a minus b times a plus b. So if we factor this using the difference of two squares formula, we'll end up with x minus 3 times x plus 3. Now, I went over that fairly quickly. If you'd like an introduction to how to factor using the difference of two squares formula, please watch my chapter 4.6 video. So we factored this using the difference of two squares formula. Neither of these two factors can be factored any further. So let's bring down the x, and we'll bring down the x plus 4. And we'll make sure to include the equal 0. Now we've factored this expression as much as we possibly can. So we've now completed step 2. For step 3, we want to set each factor that contains a variable equal to 0. To start, I'm going to copy down this factored equation right here. Now, factors are any quantities being multiplied. So x is a factor, x plus 4 is a factor, x minus 3 is a factor, and x plus 3 is a factor. Now, do all of these factors contain a variable? Yes, each factor contains the variable x. So we're going to set all 4 of these factors equal to 0. We'll set x equal to 0, we'll set x plus 4 equal to 0, we'll set x minus 3 equal to 0, and we'll set the factor x plus 3 equal to 0. Then we want to solve each of these 4 equations. This equation here is already solved. X equals 0. If we solve this equation by subtracting 4 from both sides, we will get that x equals negative 4. If we solve this equation by adding 3 to both sides, we will get that x equals 3. And if we solve this equation by subtracting 3 from both sides, we will get that x equals negative 3. So we have 4 answers here, and if we're asked to write our answer in solution set notation, our answer would look like this. And again, when you write your answer using a solution set, you are not required to write your answers in order from least to greatest, but that's how you'll commonly see the answers written in textbooks. Let's take a look at this last example. We are asked to solve this equation, so we'll follow the same steps that we've been following. Step 1, we're going to write the equation in standard form. To do that, we need to get this equation equal to 0. So I'm going to add 50x squared to both sides. Now, when we're writing this in standard form, we'll make sure to put the variables with their exponents in descending order. So we start with the variable with the highest exponent, which would be negative 12x cubed. Then we'll write plus 50x squared, and then plus 18x. And this will be equal to 0. Now this is written in standard form. For step 2, we want to factor. The first step in any factoring problem is to check for a greatest common factor. Notice the first term, in other words, the term with the highest exponent, is negative. When that's the case, our GCF must be negative. The largest number that multiplies into 12, 50, and 18 is 2, and x also multiplies into all 3 of these terms. So our greatest common factor is negative 2x. Since there is a greatest common factor, we need to factor out the greatest common factor. So we need to think through, what do we have to put inside these parentheses so that when we distribute the negative 2x, we will get this expression here. Negative 2x times 6x squared will give us negative 12x cubed. Negative 2 times negative 25 will give us a positive 50, and x times x will give us x squared. And negative 2x times negative 9 will give us our positive 18x. And then let's make sure to bring down the equal 0. Now that we've factored out the greatest common factor, we of course need to include it in our final factored form. But I'm going to ignore it for the time being as we focus on factoring this trinomial. To factor this trinomial, we need to find 2 numbers that multiply to give us negative 54. Negative 54 comes from multiplying 6 times negative 9. And we need those same 2 numbers to add to give us negative 25, which is the coefficient of the x term. The 2 numbers that work are 2 and negative 27, because 2 times negative 27 equals negative 54, and 2 plus negative 27 equals negative 25. Now in my chapter 4.5 video, we learned that when you're factoring a trinomial, if the coefficient of the squared term is a 1, once you have these 2 numbers, you can just insert them in the parentheses and write your final factored form. If the coefficient of the squared term is not 1, once you find these green numbers, the process is a little bit longer. In chapter 4.5, we learned 3 different methods. Once you find these two green numbers, you can factor by grouping, you can use the box method, or you can use the factor and divide method. I always prefer the factor and divide method, so that's the method I'm going to use here. For the factor and divide method, we start with our parentheses, and I'm going to make sure to include the equal 0. Since this is a 6x squared, we put a 6x and a 6x in the first position in each parenthesis. Then we insert these green numbers in the blanks. So we will put a plus 2 and a minus 27. Now remember, this is called the factor and divide method because once you've factored, we then have to divide. We divide each parenthesis by its GCF. So let's examine this first parenthesis here. The greatest common factor between 6x and 2 is 2, so we're going to divide by 2. Let's examine this parenthesis here. The greatest common factor between 6x and 27 is 3, so we'll divide this parenthesis by 3. So if we divide each term in this parenthesis by 2, 6x divided by 2 will give us 3x, and 2 divided by 2 will give us a positive 1. Then we'll divide each term in this parenthesis by 3. 6x divided by 3 gives us 2x, and negative 27 divided by 3 gives us negative 9. Now there's two things we're missing here. We need to make sure to include the equal 0, and also we need to make sure to include the greatest common factor. Now we've completed step 2. We've written our equation in fully factored form. For step 3, we're going to set each factor that contains a variable equal to 0. I'll start by copying this factored form down here. So how many factors do we have here? Negative 2x is a factor, 3x plus 1 is a factor, and 2x minus 9 is a factor. Now we only set factors that contain a variable equal to 0. Do all three of these factors contain a variable? Yes, they do. Each factor contains the variable x. So we'll set the factor negative 2x equal to 0, we'll set the factor 3x plus 1 equal to 0, and we'll set the factor 2x minus 9 equal to 0. Now that we've set each factor equal to 0, I'm going to solve these three equations. End up with these three answers. And if we write our answers as a solution set, our final answer would look like this.